So, all right, I'm here back again. Before I continue with what we were at, I just thought I'd show you a little picture of an electroscope that a student of mine made. And these two loops hanging on the side. You can see the side view of there what it looks like. And it's got this metal conductor here. Let's put the tube in here just so that it doesn't conduct out to the bottle. Okay, back to our picture here. So when I bring a negative rod near here, this is another cool way to charge something up. What would happen here is the negative charges would run away and the pink would have the negative charges and the yellow one would have positive charges. It's a conductor, so it can freely flow through. And then I get sneaky, I move B away. So now you see that B has got positive charges or more positive charges left on him, while B would have negative charges on it. And so there's no negative charges shown here, but there's a negative Q, the same amount of charges, which will pop up on the other side. Because if 10 electrons ran over here, you would have 10 fewer electrons here. And so when you separate them out, you'd have 10 over here that are devoid of electrons, or 10 electrons missing here, and 10 additional electrons over here. And so now you see what you've done is you just charge two objects without really using any of the charges from the outside, just using their own charges, separated them up. You essentially think of this as one object that you polarized, and then you split it in the middle so that the charges were separated. Now you have a negatively charged sphere here and a positively charged sphere over there. Okay. How many electrons does it take to make 0.25 coulombs? Well, the charge on one electron is 1.6 times 10 to the negative 5. So you would divide this number by the charge of an electron to see how many electrons it takes. This is a large amount of charge. I know it's 0.25, but that's a large number of coulombs. It's almost unrealistically large. And so you would require a huge amount of electrons to make that much. It would be somewhere close to like 10 to the 18 or so. To conduct in charged spheres with 0.8 coulombs and 0.4 coulombs negative are brought in contact with each other. It means they both have excess electrons. And so this is just like the same thing we talked about earlier. When they meet together, it's almost like you add the total coulombs that they have and then divide it by two. It's like a marriage. Two people get married, they add their wealth, they get divorced or separate, and they split their wealth. Just an example. Um, and so that'd be negative 8 plus negative 0.4, that'd be negative 1.2. Divide that by 2, I guess it'd be negative 0.6 on each one. And you can kind of see it's like the average number in the middle. One has negative 1.8, one has 0.4. If you added that together, which would have negative 1.4, divide that into 2, so it'd be negative 0.7 on each one. See what we're doing? We're just adding these two up and then dividing it by 2. Okay? So finding the average of the sum of these two. The same thing happens if there's 3, there's negative 4, plus 4, and minus 2. They're brought together, and then they're separated. Once you put them together, they'll all split up. So plus 4, minus 4, that's 0, and negative 2. So each one will have negative 2 will be divided into 3, so negative 2/3 of a coulomb on each sphere. Okay, so it'd be negative 2 is the total, and you divide that by 3, so it's negative 2/3. Okay, talk about field lines. Here's the charge of an electron. I know they've got these two additional digits. We won't be worrying about them. We're just going to pretend it's 1.6 and just kind of keep the average there to keep it less complicated for us. By the way, take a look at the mass of an electron, and it's pretty tiny, isn't it? Okay, electric field lines have a magnitude and direction. So basically, when you know that when there's a positive charge near a negative charge, how does one know the other one's there? I mean, it's kind of like the spooky stuff, right? It's like gravity. It kind of tugs you without really touching you in any way. So the same thing with field lines. And so the key thing that I want you to pay attention to here is that field lines always go from the positive charge to the negative charge. Okay? Always from the positive charge to the negative charge. They come out of positive charges, they go into negative charges. And they always come out perpendicular and go in perpendicular, so at 90 degrees. All right, so that's what field lines look like. And